Welcome, thanks for joining. We're going to be calculating here the median Q1, Q3, and IQR in the following data set. So if I'm going to do that, I'm going to have to start by finding the median. And finding the median means I'm going to have to organize this data from least to greatest. So I'm going to look here for the smallest number, and it looks like 9. Again, I always cross off just to help myself to make sure that I include all of the data. 10, I have 11, 12, 14, I have two 15s. Looking for my next smallest, it looks like 31. We make a nice leap there. 32, 36, 50, 51, and 120. Now, if I'm going to find the median of this, you want to find that center of data. So a couple different ways. You can cross off entirely if you want to. Sometimes that gets a little bit messy. So sometimes you could do checks above. Until we find that median. So here I can see my median is 15. In this case, it's dead right there in the center. So I don't need to worry about finding an average between two numbers. This was just my middle number. Now, when I go to find something like Q1 is going to come from taking the median of the left side of data. So going along here, not including the median in this case, I can see that my median is going, or my Q1, sorry, will fall in between these two numbers. So it would be 11.5. On the other hand, if I'm looking here for Q3, Q3 is going to fall between these two numbers, which is going to give me, I guess I don't want to add that in my head, 86 divided by 2, so 43. So what we found here is essentially just a median, and then another median on the left and a median on the right. The last thing that we want to find is the IQR, and your formula for that is just Q3 minus Q1. So 43 minus 11.5. And if I subtract that, I get 31.5. So that's telling me the middle 50% of my data has sort of a span of 31.5. 25% of my data falls below 11.5, and 25% of my data falls above 43. The next thing we want to talk about is whether or not there's an outlier in that data. So the first thing we need to find is the upper fence and the lower fence. Upper fence is Q3, so going back, Q3 is 43 plus 1.5 times the IQR. And I'm going to type that into a calculator real quick. 43 plus 1.5 times 31.5. No, I didn't type right, sorry. 43 plus 1.5 times 31.5, which gives us 90.25. So this is our upper fence. Anything that has gone above that upper fence is an outlier. Lower fence, we're going to take Q1, 11.5, and we're going to subtract 1.5 times 31.5. So typing that in, 11.5 minus 1.5 times 31.5 gives us negative 35.75. Looking in our data then, nothing goes below negative 35.75, but there is one number that goes above 90.25. So we can say here that since 120 goes above the upper fence, it is considered an outlier. And again, what it means to be an outlier is that if I were to go and calculate something like the mean of this set, the arithmetic average, this 120 has too strong of an impact on the overall trend of the data. So in certain cases, we will remove that outlier and say, we don't want to consider that because it's too heavily impacting our data. So that's how we calculate whether or not there's an outlier. Moving along, now we're going to make a box plot with that data set. So I said that what you want to do is first start by just making a horizontal line. And we're going to number going from our smallest to our largest. So this goes from 9 to 120. So I'll count by tens and start here at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. I don't need the rest of that line. Then we make a line at each of our 5-number summary pieces. So our 5-number summary, we had our minimum 9. So right about here. Our Q1, 11.5, about there. Our median, 15, right here. Our Q3 at 43, so huge jump there. And our maximum was 120. So notice I'm just making a line at each one of those. Then we draw a box around Q1 and Q3. So here's Q1. I'm going to connect this to turn this into a box. And then we draw whiskers to the min and max. So here I connect this box now over to my maximum and to my minimum. Having this image gives me an idea of a lot of different things. I can talk about whether or not the data is skewed. You know, over here, you've got just a little bit, and then over here, we've got a lot. So this looks like it has the idea of a skew right. I can see that the mean is over here, and because it's skew right, that means that my X bar is getting pulled to the right by this dang outlier. If I were to remove this outlier, it would change that box a lot. You know, keep in mind, my second largest number was 51. So this whisker would be ending here, and things would look possibly a little bit more symmetric without that outlier. But there, know how to make a box plot. Again, this is just the min, Q1, the median, Q3, and the max. All right, moving along, the only thing that we have left to talk about is this wonderful question at the end. For this question, I followed the process of typing everything in just from that previous slide, and I'm just going to tell you sort of what I got as a result. 5-number summary is all I want, and the standard deviation. So I can see here for me that the standard deviation is equal to 3.109, or standard deviation of the population is 3.145. Now, depending on what type of data this is, you would possibly use one of these over the other. We did use all of the data that's in my set, so, you know, standard deviation, sorry, wrong one. Standard deviation of the population is the one that we should use. Here we have a standard deviation of a sample, but I used all of this data. And then the 5-number summary. So if you did this in your calculator, you can scroll down to get your 5-number summary. It says that the minimum is 0. Q1 is, I guess I'll be consistent and use a colon here. Q1 is 2. The median is 2. Q3 is 6, and the maximum is 9. One thing I have to change here, sorry about that. Q1 was not 2. Q1 was 1. Unfortunately, I didn't read my own calculator correctly. So there, I didn't have to organize this at all. I didn't have to calculate medians. I just typed it into a calculator and it spit that all out to me. What I want to now do is create a box plot and a dot plot and describe the data. So if I'm going to create first a box plot, I'm going to number this from 0 all the way to 9. And again, I do the a line at each one of these. So 0, 1, 2, 6, 9. Connect Q1 and Q3 and draw towards your whiskers. Next, I'll do for us the dot plot. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'll use X's in this case because I was having trouble with circles. So I have, I'm going to change that color. I have 4 2s. I have 2 3s. I have 5 6 5 5 5. I have 6 7 8 8. Then 9 8 8 7. 5 4 6 2 9 9 9. And then 4 1s. 2 more 1s. 3 2s. And 1 2 3 4 5 6 7 8 9 10 zeros. So I've got this as my data. Now I want to describe the data set. So if you sort of drew a curve to represent all of your data, not the most clear. It doesn't look like, however, there is any skew happening on either side of this data. Notice there's not really a tail that points to any single one direction. So I would say that this data most likely represents a symmetric set of data, or you could even say that there's not really a trend to the data. But it does seem like if there were some middle here, there is roughly the same amount on the left as there is on the right. The examples that you'll get will be probably a lot more clear than that because I just threw together some numbers. But in the naturally occurring world of statistics, there are a lot of times a trend to all of that input, so that you can say, based off the shape, it looks skewed left. Based off the shape, it seems skewed right. Now, this dot plot didn't make it seem either way. However, this box and whisker plot, having my median here and having all of this data means that it looks more like that. So here it would seem like this is skew right. The dot plot isn't necessarily showing that as great, but this box plot does make it seem like it's skew right, since the median is towards the left. So that would mean that something like this 9 or these 8s is pulling the mean so far away from where the true sort of center of data is. All right, that's it for the examples. Get started on some of that homework.